All right, guys, here we go. By popular demand, a quick lesson on sea breezes and land breezes. So, to start with, the first thing that we have to be able to identify when we look at sea breezes and land breezes is we need to go back and look at a little bit of our information about it. So, for starters, one of the things you need to know is that not all materials absorb heat at the same rate. Okay? So, there's a term that you won't need to know until high school level called specific heat. Now, with specific heat, that's the amount of energy it takes to warm up a certain amount of material. And every type of material has a different specific heat. So when you're looking at things like sand, you're normally looking at around 800 joules of energy, okay? Which seems like a tremendous amount of energy until you find out that water, on the other, besides sand, water, okay, just normal H2O, needs somewhere around 4,200 joules of energy. So you're looking at it takes about 5 times more energy to warm up the ocean water or seawater than it would to warm up just normal sand. Now, if you stop and think about it, that really makes sense because when you go to the beach in the middle of the day, when you're walking around on the sand, it's burning your feet, okay? But when you run over and you step into the water, it cools everything off. And that's because the sand has been able to warm up much, much faster than the ocean water because it takes less energy. So, the whole reason we have land and sea breezes is because of this fact, the specific heat. So, we'll take sun. All right, so our sun is shining down on us. It's shining down on us. It's shining down on the sand. It's shining down on the water. Okay, it shines with the same amount of energy everywhere. The only difference, though, is that the energy that hits the sand, you only need a very small amount to start warming the sand up. So the sand gets really hot really fast. The water, on the other hand, takes a tremendous amount of time to warm up, not to mention the fact that the water keeps moving around and circulating. So even when the top of it's warming up, you have to actually warm up a huge amount of it because the ocean is much, much larger than just the sand that's sitting here. So our sand is boiling hot. The water is still pretty cool. Well, we look at first conduction and convection. If these little air molecules that are floating around by the sand touch the sand, they're going to warm up. It's simple conduction. When two materials heat, there's a transfer of heat energy. So all of these air molecules around here are going to warm up. Then we begin conduction or convection. Convection says that warm fluid molecules, any warm or hot air molecules, are going to naturally rise. Okay, so these molecules are all rising up. Now, if you've ever been to a beach and you know that it's really hot and we know that air is rising up, the one thing you should have noticed is you didn't suffocate. Okay, you were still able to breathe even though all of this air was rising up. That's because when this air pulls up, okay, it creates a suction. It pulls in other air, okay? So all of this nice cool air off of the ocean gets pulled in like that. So all of this air gets pulled in so that one, you can still breathe, but also there's that transfer of energy. So this continues to happen. This air rises up. Once it reaches a certain point, it gets high enough into the air that it starts to cool off. Cool air starts to fall back down and it gets replaced, and we create a convection current like we've talked about in other areas. So that's what's happening. Now, when we look at what's happening to you while you're standing on the beach, okay, yes, I'm on the beach, my feet are hot, but if you look, I have this nice cool sea breeze that's getting pulled off and cooling off the rest of me. This is how sea breezes are formed, okay? They're formed by convection currents, okay? The sand is warm, it warms up the air rises, it pulls in cool air off of the sea. So when you're standing on the beach in the middle of the day, you should have a nice little breeze coming off of the ocean. That's what generally should be happening, okay? That's what we have when we have daytime, we have sea breezes. And notice that the sea breeze is named sea breeze because of where it originates. We name most of our winds based off of where they come from. Sea breezes come off of the sea, so that's what they're called. All right, hold on for a second. All right, pause you for a second and notice that time has gone by. The sun has set. Okay, it's now nighttime. So it's nighttime outside. Now, the one thing that happened earlier is sand warmed up really fast because of its low specific heat. Okay, well, guess what? It warmed up fast. It will also cool off extremely fast, at least compared to the water. So the water may not have ever gotten as warm as the sand, but the energy that it has, it's going to hold on to because it takes a long time for water to lose energy. All right. So the water's going to hold its energy and stay warmer than what it would have normal. The sand is going to cool off really, really fast. So now at nighttime, when we look at it, we have a warmer water and a cooler sand. So just like before, our warm area, it's going to warm up the air around it. These little molecules are warming up here, which means they're going to rise up. Okay, that's simple convection. Warm air rises. So if all of this air rises up, same as before, when warm air rises, it needs to be replaced. So now it's going to be pulling air from off of the land, cooler air. And same as what happened before, we're going to end up creating a convection current. This air is going to rise up. It's going to go ahead and move up. It's going to cool off up here. Once it cools off, it's going to start falling back down, and it's going to create this current of air. All right, and that's going to happen throughout the course of the night. Now, during the nighttime, what we should see is that we should have a land breeze, a breeze going from the land out to the sea. All right, and it happens for the exact same reason that it happened during the daytime, convection. Wherever it's warm, air is going to rise up and it's going to pull air from the other sections. And it's always going to create these little currents. All right, so as a recap, nighttime, we get land breezes because the water has remained warm because it's been heating up all day and it holds on to its heat. The sand has cooled off a great deal, so it's much cooler. So we have heat rising over here and it's pulling out the cool air. During the daytime, the exact opposite happens. Sand is boiling hot during the daytime. The ocean is still cool, so we have heat rising on this side, pulling in air, creating the sea breeze. Okay, so you get sea breezes during the daytime and land breezes during the nighttime, and it's all based off of which one is warmer and what time it is. All right, so I hope that helps to make a little more sense for this, and I will talk to you all later.